Hello everyone. Today we are going to start lecture 02 of class 8 mathematics chapter number 3, which is understanding quadrilaterals. In this lecture we are going to talk about quadrilaterals, right? We have already studied what is a polygon. We have already studied what is a curve. So let us take our study to the next level and find out what is a quadrilateral. When we studied polygons, we saw that polygon of n is equals to 4. That is, polygon having 4 sides are called quadrilaterals. Polygons having 3 sides were called triangles, and of 5 sides we call them as pentagons. So we are talking about polygons which have 4 sides. Okay, so what does a quadrilateral actually means? What is the definition of quadrilateral? Let us talk about that. So its definition says that let A, B, C, D be 4 points. Let A, B, C and D be 4 points in a plane. 4 points in a plane. Now these 4 points would become 4 vertices of the quadrilateral, right? 4 points in a plane such that. So what is the condition that these 4 points should satisfy? So the first condition is no 3 of them, such that no 3 of them are collinear. That is, no 3 points should lie in a same line, otherwise it would become a triangle. Okay, let me explain it at hand. Suppose these are 4 points and these 3 points becomes collinear. Now suppose the 4th point is this. Now you can clearly see it does not form a quadrilateral, because if you try to join this, let me show you. If you try to join these 3 points, they will form a straight line, and again then you try to join them, you will get a triangle. You will not get a quadrilateral. Okay, so you can clearly see no 3 points could be collinear. Also, if you talk about popular quadrilaterals, let it be a quadrilateral, right? Now you can clearly see all the 4 points, only 2 points are collinear, because 2 points are always collinear, but no 3 points are in the same straight line. So you can clearly see the meaning of this first condition, that is no 3 points should be collinear. Let me talk about the second condition. The line segments, the line segments AB, BC, CD and the line segments AB, BC, CD and DA do not intersect except at their endpoints. Do not intersect except at their endpoints. Okay, so let me tell you what I am trying to say. With these two conditions, you can clearly say that you can have quadrilaterals like, you can name them as A, B, C and D. Clearly this quadrilateral follows all the conditions. No 3 points are collinear, right? Otherwise we would have got a triangle. The line segments AB, BC, CD and AD, they all are intersecting but only at the endpoints. See, AB is intersecting with another 2 line segments only at their endpoints. This line segment BC is intersecting with CD and AB at their endpoints B and C. Also this line CD is intersecting at their endpoints. So all of the line segments are intersecting at the endpoints. So this is a quadrilateral. Now what does a quadrilateral can look like when it is intersecting at one point? Okay, so let me tell you that is what is not a quadrilateral. Again we can have this line segment. Okay, now also you have 4 points A, B, C and D, and also no 3 of them are collinear. Okay, the condition is still satisfying, but it is voiding the second condition. Second condition simply states that line segment cannot intersect at points which are not the endpoints, and this is intersecting at this. Clearly this point, let me call it P, is not endpoint of any line segment, and that is phi. This is not a quadrilateral. Why? Because it do not follow second property or second condition, that they do not intersect. This is a quadrilateral. Okay, this is a quadrilateral. So in this way you can clearly see that what is a quadrilateral, what is not, and this sums up the definition or introduction of what is something called quadrilateral. So it is a polygon of 4 sides. Which kind of polygon? In which all the 4 points are such that no three are collinear and the line segments do not intersect at other points than the end points. Okay, so let us talk about some properties of quadrilaterals. Okay, so see ABCD, here is a quadrilateral. Now let us talk about what are its sides, because each polygon has vertices and sides. So I've already defined what are sides. Sides are nothing but the line segments which form the boundary of the quadrilateral. So there are four sides. So with the help of the figure, let me point out the sides. So we have four sides, namely AB, BC, CD and AD. So these are the four sides. Okay, AB, BC, CD and AD. These are four sides, or you can call it DA, whatever you want. These are actually the four line segments which are forming the boundary. So these are four sides. Now what are adjacent sides? What are adjacent sides? What are these? Let me talk about them. So what are adjacent sides? See, obviously it has four sides, but two of the sides will always be nearby each other. Okay, since AB is adjacent to AD, right? Also AB is adjacent to BC. Adjacent means nearby sides. Sides which have one vertex as common. See, this line segment AB and this line segment BC have a point B common, and that is why they are called adjacent sides. So there are adjacent sides. For example, AB and BC, these are adjacent. We have a pair of adjacent sides. Okay, then we have AB and AD as adjacent sides, right? So AB, BC, AB, AD. You can have BC and CD as adjacent sides, right? You can have CD and DA. You can have CD and DA as adjacent sides, right? So there are pairs, because CD and DA both have D common. Okay, you can have DA and AB, which we have already counted. So there are four pairs of adjacent sides, right? So the sides which are nearby each other, or you can clearly, by the logic, it follows that the sides which have one point as common are called adjacent. So what are opposite sides? If they are adjacent, that is nearby, then there must be something called opposite. So let us talk about it. So what are opposite sides? Now opposite side means sides in front of each other, okay, which are not adjacent. Clearly, if you talk about AB is opposite to CD, because AD and BC are both adjacent. Okay, so what is opposite? When they do not have any point in common. So AB and CD do not have any point in common. So you can have two pairs of adjacent sides, which is AB and CD, and similarly you can have BC and AD. Again, BC and AD are also opposite because they do not have any point in common. Okay, and lastly we have diagonals. Now what are diagonals? This figure do not have diagonals. I'll show it. This is on purpose so that I can show you what diagonals actually are. So what are diagonals? When you join opposite vertices, right? A and C are opposite vertices. When you join these vertices with the help of straight lines, you call them as diagonals. Okay, so in this figure ABCD, which is a quadrilateral, AC and BD are called two diagonals. So let me draw them. Okay, so these are diagonals. You can also call them when you join the opposite ends of adjacent sides. Okay, obviously AB and BC are adjacent sides, so they have a point common. So when you join the non-common points with the help of line segment, you get diagonals. So what are diagonals? Here we have two diagonals, which are AC and BD. So these are two diagonals. Okay, so these are the line segments joining the opposite vertices, or you can say two non-common vertices of adjacent sides. Again, these are called diagonals. So every quadrilateral has four sides, four pairs of adjacent sides, two pairs of opposite sides, and two diagonals. Okay, so this was all about sides, adjacent sides, opposite sides, and diagonals of a quadrilateral. Now let us talk about angles, adjacent angles and opposite angles. Now let us focus on the vertex part. Till now we have focused on the part which contains length, but again there is something to be measured as angles. So let us talk about them. So angles. Now in a quadrilateral, these 4 points are called 4 vertices, and these 4 vertices form 4 angles because at these points two sides intersect, and when they intersect, they obviously do so at a particular angle. So you can clearly see this is an angle, this is also an angle. Line segments AB and AD also intersect at an angle. This is also an angle. Okay, this can be anything from 0 to 180 degree. Even more than that, it will be a case of convex polygon. We'll talk about it later in this lecture, that what is a convex quadrilateral, but for now it can be any value. So these are angles. So we have four angles. We have four angles in a quadrilateral, namely angle A, angle B, angle C, and angle D. You can clearly see ABCD as four angles. You can also call angle A as angle BAD or angle DAB. That is also the name of angle A. Similarly, angle B can be called as angle ABC or angle CBA. Okay, these are again conventions, but since they are vertices, we can directly call them as angle A, B, C, and D. And it is understood that when we say angle A, we mean interior angle, not the reflex angle A. Let me show you the concept of reflex angle. Suppose if this is an angle A, if this is angle A, then this outside angle is called reflex angle A. That is 360, because this complete circle will form 360 degree. So if this angle A is 90 degree, this red portion, this red angle, that is reflex angle, would be 360 minus 90 degree. That is 360 minus angle A. So this was the concept of reflex angle. So whenever we talk about angle A in a quadrilateral, we always talk about the interior angles. Otherwise, it would be mentioned that we are talking about external angles. So we have four angles. Now, what are adjacent angles? We call angles adjacent when they have a common arm. Okay, see, for angle A, the two arms which are, what are arms? If this is an angle, let's suppose it is angle P, then this side's OA, let me call it OX, and this side OY. Then OX and OY are called arms of angle P. That is, these are actually the line segments in which angle P is getting formed. Okay, so when we are forming angle P, we are forming it on the basis of or in between the arms OX and OY. Okay, so these were the line segments which are forming the angles. So these are the arms. So adjacent angles are those angles which have a common arm. So AD and AB are arms for angle A, and AB and BC are arm for angle B. So AB is the common arm for angle A and B. So we have angle A and angle B is adjacent angles. Similarly, angle B and angle C have an arm common, which is BC. Angle C and angle D have an arm common, which is CD. Similarly, angle D and angle A have an arm common, which is AD. So we have four arms as common. So angle A, B, C, C and D, and D and A. So four pairs of adjacent angles that we are getting. So it is clear that adjacent angles is nothing but the angles which have a common arm. Now, what are opposite angles? Certainly, if we have something called adjacent, we have nearby angles. So we must have opposite angles. So again, it is the same principle as we talked in the sides. So what are opposite angles? Sides have a common vertex. Adjacent sides had common vertex. Adjacent angles have common arm. Similarly, opposite sides were those which do not have anything as common, which do not had any point common. Similarly, opposite angles are those which do not have an arm common, right? So angle B and D, you can clearly see their arms for angle B is AB and BC, and for D it is CD and AD. So no arm is common, right? So angles which do not have a common arm are called opposite angles. For example, we have two pairs of opposite angles, angle B and angle D, also angle A and angle C. So these are opposite angles. So we have angles, four angles, namely A, B, C and D, adjacent angles, and then opposite angles, right? So these are opposite angles. So this was all about the angular part of a quadrilateral. Okay, so there are always two parts in a polygon, one which can be measured in length, which are sides, and one which can be measured in the angles, which are generally the interior angles. Okay, so now let me talk about convex quadrilateral. As I have already mentioned that an interior angle in a quadrilateral can be greater than 180 degrees. So what it means when an interior angles becomes more than 180 degree. You can clearly see in this quadrilateral ABCD, this angle C is an interior angle, but certainly this angle is greater than 180 degree. Okay. It changes nothing, but it changes the fact that now this quadrilateral is convex and this quadrilateral will be called as non-convex. That is, it is called a concave quadrilateral. Okay. In this chapter, we are going to focus on convex quadrilateral. So let us first talk about that what is a convex quadrilateral and how do we identify one. Okay. So the definition simply says that a quadrilateral is called a convex quadrilateral Let us say quadrilateral is called a convex quadrilateral, comma, if the line containing any side of the quadrilateral has the remaining vertices on the same side of it. Now what this definition actually means, let me tell you. It says that a quadrilateral is called a convex quadrilateral if a line containing any side. Suppose AB is the line which contains the side AB. AB is a line segment, it is not a line. So let us suppose that there is a line extended which contains the side AB. Then the other two vertices should be on the same side. You can clearly see if I take this line. Let me take this line. Now this line contains the line segment AB. There is a side AB. Now you can clearly see the remaining vertices are on the right side, on this side of the line. Okay. Similarly, if you take AD as the line containing this side AD, then you can see the remaining vertices BC are on the same side of this line segment, that is on the upside. Similarly, for CD, A and B are on the left side of this line, and similarly if you take the line this BC, then you can clearly see that A and D, that is the remaining vertices, are on the same side of the line, right? So this was the concept of convex polygon, concave polygon, right? Convex polygon and concave polygon. Now what is concave polygon? Obviously concave polygon will not follow this definition. You can clearly see if you take the line as AB, suppose I take this line AB, then the vertices B, C and D lie on the same side. Okay. If I take the line AD, then also the same case happen. But if I take the line BC, now this is the line containing the side BC, then you can see that D is lying on the left side, or you can say on the downside of this line, and the remaining vertex A is on the upside. That is now the vertices are on the opposite side. Let me show you this for CD also. Suppose I take this line. Obviously this line is containing the side CD, but the remaining vertices A, one is on the one side and B is on the other side. So the vertices are not on the same side. So this was the definition, but you can also identify concave or convex polygon on the basis of some points. Let me show them. There are also some other points which can help you. So let me give the first one as that in a convex polygon or in a convex quadrilateral, for this case, the measure in a convex quadrilateral, the measure of each angle, we are talking about interior angle, the measure of each angle is less than 180 degree. You can clearly see all those four angles are less than 180 degree, right? But in this case, this angle C is greater than 180 degree, so it is concave, and this quadrilateral is convex quadrilateral. Okay, you can also have one more way of identifying it. Okay, you can also get this by that both the diagonals of a convex that both the diagonals of a convex quadrilateral lie wholly in its interior. Both the diagonals of a convex quadrilateral lie wholly in its interior. Now you can clearly see if I make the diagonals, then both the diagonals BC and D lie inside it. But when I try to make diagonals here, the diagonal AC will lie inside, but the diagonal BC is on the outside of the quadrilateral. You can clearly see when I join the opposite side, AC is well inside the quadrilateral, but diagonal BC is outside the quadrilateral. That is why it is concave and it is convex. Okay, you can also say that line segments. You can also say that line segments joining any 2 points. You can also call this as line segment joining any 2 points inside the quadrilateral should be completely inside the quadrilateral. Okay, they should not be outside. Similarly, if you join AB, it is a line segment, so it is well on the quadrilateral. If you join AC, then it is inside the quadrilateral. BD is also inside. Okay, this remark can be rewritten or resaid as that if you join any 2 points in the interior of a quadrilateral, it should be completely inside. Again, AC was the 2 points. When we joined them, it was inside, but when we tried to join BD, then our diagonal was outside the quadrilateral, and that is why this is a convex quadrilateral and this is a concave quadrilateral, right? So this was all about it, whether a quadrilateral is convex or concave and how can you find out the one. Okay, now let me talk about an internal important property which is called internal angle sum property. Now what is this angle sum property? We already know that angle sum property simply says that sum of all interior angles of a polygon is constant. For triangle it is 180 degree. We already know that for a triangle sum of all interior angles is 180 degree. Now what is interior? Interior means we are talking about interior angles. I have already cleared that whenever we say angle, we mean interior angles. Okay, otherwise it would be mentioned if we talk about the exterior angle. So let us talk about it. What interior angle sum property of a quadrilateral says. So it says that the sum of the angles, it says that the sum of the angles of a quadrilateral, it says that the sum of the angles of a quadrilateral is 360 degree, or you can say 4 right angles. So the sum of angles of a quadrilateral is 360 degree. So this is what interior angle sum property of a quadrilateral simply says. So let us find out how it is doing so. Okay, so let us talk about the proof of how this sum is 180 degree. And what we'll use in this proof, we'll use the angle sum property of a triangle. So the first thing which we would do is we would have a quadrilateral ABCD. So we will take, let ABCD be a quadrilateral. Let ABCD be a quadrilateral, right? So we have a quadrilateral ABCD. Okay, now we need a diagonal for this purpose. So let us take the diagonal as AC. Okay, so since this is the construction, so it would be dotted. So now we will have join AC. So we have joined AC. Okay, so now AC is one of the diagonal. Now clearly we can say that this angle A and this angle C have been divided into 2 angles. So let me give them some names. Let this angle be called angle 1 and this be called angle 2. Similarly, this be called angle 3 and this angle be called angle 4. From construction, we have angle A is equals to angle 1 plus angle 2. Similarly, we have angle C is equals to angle 3 plus angle 4. Okay, so these were the angles. Now we know that sum of all interior angles of a triangle is 180 degree. So let us use that property to prove our internal angle sum property. In triangle ADC, angle 1 plus angle D plus angle 3 is equals to 180 degree. Okay, in this triangle ADC we have three interior angles as angle A, angle D and angle C, that is angle 3. So these three angles will form 180 degree. Now how do we get this? By angle sum. We got this by angle sum property of a triangle. So what does an angle sum property of a triangle simply states? That the sum of all interior angles of a triangle is 180 degree. Okay, so let this be called as equation number 1, right? Similarly, in triangle ABC, angle 2 plus angle B plus angle 4 is equals to 180 degree. Again, it is from the angle sum property of a triangle. So we have these two equations. Now if we add these equations, now let me add these equations. So we will get equation 1 plus equation 2 will implies that angle 1 plus, you can create here also, it was 1, it was 2, it was angle 3 and it was angle 4, right? So we had angle 1 plus angle D plus angle 3 plus angle 4 plus angle B plus angle 2 is equals to 180 degree plus 180 degree. Now pairing the angles, we will get angle 1 plus angle 2 together. Then we can have angle D. We can have angle D. Then we can have angle 3 and angle 4 together. And then we can finally have angle B. So we would get them as 360 degree, right? Because 180 plus 180 is 360. Now we have already seen that angle 1 plus angle 2 is nothing but angle A. Okay. Then we have angle B. Then angle 3 plus angle 4 is nothing but angle C. And then we have angle D. So the sum of all interior angles of a quadrilateral is equals to 360 degree. Hence proved. Okay. So we can clearly see that the sum of all interior angles of a quadrilateral is 360 degrees. So this was the internal angle sum property. But again, we are interested in that this was the quadrilateral. So we have 4 sides. For triangles we had 3 sides. Can we find the sum of interior angles of a pentagon or a hexagon? Okay, that is when a quadrilateral, when a polygon has 10 sides, can we find the angle sum property? Can we apply the angle sum property? Yes. Polygons of any side follow some angle sum property. So interior angles of polygon of any sides is constant. It would be different, like for triangle it is 180, for quadrilateral it is 360. Similarly for pentagon it can be anything. Okay, so let us find out. Let us define a general formula for this purpose. So now we are going to talk about sum of all interior angles of a polygon of n sides. Suppose a polygon has n sides. So what is the sum of all interior angles of a polygon? Okay, so let us talk about it. So the formula simply says that sum of all interior angles of a polygon of n sides is given by the formula is n minus 2 into 180 degree, right? So the sum is given by this formula, which is n minus 2 into 180 degree, where n should be greater than equal to 3. And it is an obvious condition, because you cannot form a polygon with less than 3 sides. You should have at least 3 sides. Then the polygon would be triangle, and that would be the smallest polygon. Okay. How can we apply this formula? Let me show you some explanation. For n equals to 3, that is a triangle. That is a triangle, comma. Sum of interior angles would be, let us put 3 in this formula. So we will get 3 minus 2 into 180 degree, which is which is 180 degree, which is true. Okay, so angle sum property for triangle says that all the sum of all the angles is 180 degree. Let us find out for quadrilateral if this formula is correct. For n equals to 4, that is a quadrilateral. Now what is the sum? We know that the sum is 360 degree. We have just defined it. Let us see the formula gives the same result. When you apply this on the formula, you put n equals to 4, you will get 2 into 180 degree. So yes, it is 360 degree. Now out of curiosity, let us find out for n equals to 5, that is pentagon. Okay, that is a pentagon. For a pentagon, let us see what is the angle sum property, or what is the sum of all interior angles. So the sum would come out to be 5 minus 2, because we'll put n equals to 5 here, into 180 degree. So it will be 180 into 3, which is 540 degree. So the sum of all interior angles of a pentagon would be 540 degree. Similarly, you can find out for hexagon, heptagon, octagon. Okay, you can put n, you can give n any value greater than or equal to 3, and you will find the angle sum property for that particular polygon. Okay, now it does not matter the polygon is regular or not. That is, what is a regular polygon? We talked about a polygon which has all the sides equal and all the interior angles equal. It does not matter, because for the quadrilateral for which we have proved the angle sum property, it was not regular, it was irregular. Okay, all the interior angles were different, of different measure, but still the sum came out to be 360 degrees. So this formula does not care whether the internal angle are same or not, that is, the polygon is regular or not. But if the polygon is regular, now the second formula which I am going to write is valid only for the polygons which are regular. So it says for a regular polygon, of n sides, where again n is greater than or equal to 3, comma, for a polygon of n sides, each interior angle is equal to what? N minus 2 into 180 degree, that is the sum whole upon n. Okay, so this formula simply says that if you have a regular polygon, then all interior angles are same. Okay, so each angle will contribute the same amount towards this sum. So if you divide by the number of angles, you will get the sum of each angle. You will get the measure of each angle. That is, if in a triangle all the three angles are same, okay, so divide the sum by 3, you will get 60 degree. And you know that equilateral triangle is a regular polygon, regular triangle, and each interior angle is same. Similarly, for a quadrilateral, if each interior angle is of same measure, because it is a regular polygon, then it must be same. So all the four angles are of equal measure. Divide the total sum by 4 and you will get 90 degree, 360 upon 4, which is the measure of each interior angle of a regular quadrilateral. What was a regular quadrilateral? A square. Similarly, if a pentagon is regular, that is, all interior angles are same, then all the 5 angles would be same. Then all the 5 angles sum would be, if it is 540 degree, you can divide 540 by 4 and you will get the sum of each interior angle. Okay, which will come out to be 108 degree. So this formula is valid only for regular polygon. Okay, and if the polygon is irregular, you can find the sum by this formula. But if it is regular, then each interior angle will contribute the same amount towards this sum. So it was all about sum of all interior angles of a polygon of n sides, right? Now let us have some questions regarding these concepts. So the first question is, the angles of a quadrilateral are respectively 100 degree, 98 degree, 92 degree. Find the fourth angle. So it is a very easy question. Simply, we know that for a quadrilateral, sum of all interior angles is equals to 360 degree. So let the fourth angle be x. Let the fourth angle be x degrees, right? Let the fourth angle be x, or you can call it as x degree. Then from the angle sum property, sum of all the four angles, that is 100 degree plus 98 degree plus 92 degree plus x is equals to 360 degree, right? X equals to 360 degree. So we can take all of them to the RHS and we will get 360 degree minus 100 degree minus 98 degree minus 92 degree, and we would get X as 98 minus 92. This would be 190, and 190 and 100 would be 290. So this will be 360 degree minus 290 degree. So the X or the fourth angle would come out to be 70 degree. You can clearly verify that if you add 70 degree to these three angles, you will get 360 degree. So this was a simple question based on the property of angle sum property, okay, of a quadrilateral. Let us take another example. Now this example simply says find the value of X in the following figure. Okay, so we have to find the value of X. You can clearly see ABCD is a quadrilateral. Okay, so we can firstly verify that ABCD is a quadrilateral, right? So ABCD is a quadrilateral, so it must follow angle sum property, which simply says that angle A plus angle B plus angle C plus angle D is equals to 360 degree. So angle A is 50 degree, angle B is X, angle C is what, 120 degree, angle D is again 130 degree, is equals to 360 degree. So we will get X as 360 degree minus 120 degree minus 130 degree minus 50 degree. We have transposed all these terms to the RHS. So we would get X equals to 360 minus 120 equals to 240, 240 minus 130 equals to 110, and 110 minus 50 degrees equals to 60 degrees. So the value of X is 60 degree. So angle B, or you can see the fourth angle, should be 60 degrees. So again it was the question on angle sum property of a quadrilateral. Now let us take one question on the angle sum property of a pentagon. Firstly, let me give the name. Let it be A, B, C, D and E. So this has 5 sides, A, B, B, C, C, D, D, E and E. So it is a pentagon. Okay, and we just carried out the calculation that a pentagon has sum of all interior angles is 540 degree. So we'll write A, B, C, D, E is a pentagon, right? So this angle A plus B plus C plus D and E should be what? Should be 540 degree. So first let us calculate angle C and angle D. You can clearly see angle, let me give this point as X and this point as Y. Okay, then we will have angle BCX plus angle BCD equals to 180 degree. That is this angle 70 degree, and this BCD, that is this angle, would be 180 degree. How? Linear pairs. These are linear pairs, right? So sum of these angle is, see clearly it is a straight line. XCD is a straight line, so it will be 180 degree. So angle BCX is 70 degree plus angle BCD is equals to 180 degree, which simply says that angle BCD equals to 180 degree minus 70 degree, which would be 110 degree, right? Similarly, you can apply this linear pair property here also. So here we have angle EDY plus angle EDC is equals to 180 degree. Again the angle sum property here also, right? So we will get angle EDC, angle EDY is 60 degree. So the angle EDC would be 180 degree minus angle EDY, which is 60 degree. So we will get 120 degree. So now it is 110 degree, 120 degree. These are X and this is 30. So we have to find the value of X, right? Since ABCD is a pentagon, so angle A plus angle, you can call it angle B. Okay, you can clearly call it angle B plus this angle BCD plus this angle EDC plus angle E. That is, sum of all the 5 angles would be 540 degree. This is the angle sum property of pentagon, right? Now angle A is 30 degree, angle B is X, angle BCD we have just calculated it to be 110 degree, angle EDC we have calculated it to be 120 degree, and angle E is again X, and we are getting the sum as 540 degree, right? Simplifying the equation, we will get x plus x, that is 2x, equals to 540 degree minus 110 degree minus 120 degree and minus 30 degree. That is, we have taken all these 3 terms to the RHS. So what we would get is, we would get as 2x is equals to, calculating this, we will get 110, this is 230 and 30, 260 degree. So 540 minus 260 degree we will get as 280 degree, right? So the value of x, dividing both the sides by 2, we will get x equals to 140 degree. So the value of x is 140 degree, right? So this was the question on angle sum property of a pentagon. Now let us take the last question. In a quadrilateral ABCD, the angles A, B, C and D are in the ratio 1:2:3:4. Find the measure of each angle of a quadrilateral, right? So the ratio of in a quadrilateral ABCD, the angles A, B, C and D are 4 angles. So the ratio is given. Now we do not know the actual angles, so they must have some common factors. So after cancelling them, we are getting 1:2:3:4. So let us take the angles to be, let the angles be as angle A be x, angle B be 2x. I'm assuming the common factor to be x. Okay. Angle C equals to 3x. Similarly, we have angle D is equals to 4x. So if these are the angles, you can clearly see the common ratio would be 1:3:4, 1:2:3:4, and x will cancel out. But again, since they are the angles of a quadrilateral, they should follow the angle sum property. Since ABCD is a quadrilateral, so angle A plus angle B plus angle C plus angle D, that is all, angle C and angle D should be 360 degree. So we have simply x plus 2x plus 3x plus 4x is equals to 60 degree, 360 degree. Adding them will get 7 plus 2 plus 9. So we have 10x is equals to 360 degree. Dividing both sides by 10, we will get this common factor x as 36 degree. So this is the common factor, okay, which we have cancelled from these angles to get the ratio 1:2:3:4. So now we can easily calculate the angles as, so angle A is equals to x, so it was simply 36 degree. Angle B is equals to 2x, which is 2 into 36, that is 72 degree. Angle C equals to 3x, that is 3 into 36, so it would be 108 degree. And angle D equals to 4x equals to 36 into 4, so we will get 144 degree. So this was all about this question. Again, it was the question on angle sum property of quadrilateral. Okay, so this was all about this lecture in which we talked about different types of quadrilaterals. Okay, now what are different types of quadrilaterals? That is, we have talked about convex quadrilaterals and concave quadrilaterals. Again, the classification of quadrilaterals will be covered in the separate lecture. Okay, so in this particular lecture we talked about concave and convex quadrilaterals, their side, their angles, opposite angles, and the important part, which is the angle sum property, and we solved some of the questions. Okay, so thank you for watching this lecture till end. This was all about this lecture. I'll see you in the next lecture. Till then, goodbye.